expiring the whole minute, even if I turn it off. It'll as soon as those initial 5 seconds has passed, I can just push the joystick down and it will turn off and not activate again. So, and then I set the minutes and the hours at which I want it to go off. So the alarm I do with this do function over here, which will turn the red LED of the clock on, and it will turn on the music function, which we'll see down below, which is to activate the buzzer, so it'll produce a sound, a music. And as soon as I move the joystick on the X axle above 700, it'll turn off the LED, it'll turn off and the alarm. So and it'll wait 2 seconds just so that it's not always activating. And then analog function. And then next, so after the alarm is dealt with, or if the alarm is not set on, the regular function, the alarm time function will turn on, which is where I tell the servo what time it is and where to position himself. You'll see that function over here. This block over here is for Bluetooth communication, which I don't have for now, so I won't explain. And this is where I start active. This is where these two if blocks is where I activate where I toggle the lamp on or off. So if joystick X is below 300 and the relay was low, it'll turn it on. If vice versa, I press the joystick on the X axle below 300 and the relay was high, it'll turn it off. And afterwards, the logic is kind of like this. I use the joystick as a toggle. So on these three conditions is where I turn on the RGB of the lamp on, the function on. Now, I turn on the auto processing variable on, and then if the joystick was pressed above 700 and the auto processing of the sequence of the RGB of the lamp is off, it'll turn that variable on, and that will, on this if and else condition, if the auto processing variable is 1, which was set up above, it'll turn on the auto RGB 2 function, which is the lamp RGB module. And if, on the other hand, I go again to the joystick above 700 and the process was running, the variable auto processing will be set to 0, and in this if condition, it'll go into the else and turn everything off and not do the sequence of the RGB module. In other words, it'll turn it off. So this is exactly the same process, but for the clock RGB, same thing. And then this is the joystick on the Y axle. If I move it below 300, it'll turn the clock RGB LED. It'll simply turn it on, as you can see over here. Clock value. Well, the clock value, it'll just turn it on, and I can change that intensity with the potentiometer that you saw. So, but it'll only turn that light on, just so that at night, for example, if you want to be able to see the time on the analog clock, you'll be able, as you saw on the video. And so here you go. So this is the if cycle, that if the clock light variable is set on, it'll turn on the lights. It'll read the potentiometer. And it'll store to the clock light value variable the mapping of the value that is set on the potentiometer, and it'll be written to the green LED of the RGB from the clock. Now this is the loop function. This is where the loop function is only this. It's only from down here, up to here. All the rest that you see down here are the functions that I referenced above. Now let me take you through them real quick. Now this is the lamp clock function. It is simply just printing the time to the serial monitor and storing the real time into the respective variables. And the RGB function, both the RGB function of the module and of the right over here and of the analog clock RGB are the same. I only changed the LED lights, obviously. So then we go into the analog time, where I take the minutes and the hours and I set them to my servo. Now how do I do that? How do I set it to, as you know, time goes from 0 to 24, red in the RTC. So I had to divide the scale of the analog clock between 0 and 12. So if hours equals 12, I replace the hour variable with the value 0. If it's 13, I move to 1. 14, I move to 2, so on and so on, to keep the scale between 0 and 12. And then I move to the function where I calculate the total amount of minutes until which are equals to the present time. And then I write that value to the servo. I write the value to this variable, which is the variable that I'm going to use on the servo. I map the value of the total minutes variable between 0 and between 720, which is the total minutes of the scale from 12 hours. So 720, which is a total, to 0 to I reverse it because my 180 degrees are on the other side. So, but from 0 to 180 degrees, and that will give me the angle that is respective to the total amounts of minutes that equals the real time. So in this function over here is where I get the value from the potentiometer to use accordingly. This is the analog clock RGB, which is the same as the module, and finally the music function. I use the tone. I use the tone function, and I imprint the frequency of the notes. This is G. I think it's, I don't know the other ones. I'm not going to say because I may be wrong, but I have about 4 or 6 different notes over here played in four sequences. I have 2 that are the same, the first and the third, and the second is different from the last, which is different from the first and the third. So this is the sketch.